listener phone call.
Kaku, this is Larry Chan from Manhattan, hearing you on Genesis. I'd like to ask about the mathematics behind mazes. Is there a field of mathematics that specifically discusses mazes? Is it possible to make a four-dimensional maze that includes a factor of time? For example, if time travel became possible, might it be possible to create a maze where you have to travel to and fro through time in order to pass the maze? Maybe a section of the pathway is missing and only accessible if you go to a certain year. Or maybe you have to wait for a tree to grow in order to reach a particular location. Would quantum computers be able to generate this kind of puzzle?
Okay, well, you ask a very interesting question. First of all, a maze. Is it possible that mathematically we can represent a two-dimensional maze that we put a mouse in, for example? And the answer is yes, okay? Think of a checkerboard. If I have a checkerboard, I could put a number associated with each of the squares inside the checkerboard. These are called Cartesian coordinates. It was Descartes, the mathematician philosopher, who came with this idea of every point in space associating a number. On a two-dimensional chessboard, for example, every point on the chessboard can be represented by two numbers, the x and the y coordinate, the length and the width coordinate. And so he introduced the concept of coordinates, Cartesian coordinates, by which we can measure the location of any object. This means that if I delete some of the positions within this Cartesian coordinate, I will get a maze. And then I can put the mouse in the maze, and the mouse will then transverse through all the different points that are still consistent with the rest of the maze. So creating a maze out of two dimensions is simple. Simply take a chessboard, remove some of the squares, and you have a maze. A three-dimensional chessboard is also possible. If you're a fan of Star Trek, they regularly play three-dimensional chess on Star Trek. It's the same thing. This time, you have not just a two-dimensional flat chessboard, you have a three-dimensional chessboard, a cube. And again, three numbers will describe every point inside this cube. These are called Cartesian coordinates in 3 dimensions. Then Einstein comes along and says, 3 dimensions is not enough. You need a 4th dimension. A 4th dimension which we cannot see, but mathematically it's possible to construct a maze in 4 dimensions. Every dot inside the maze can be represented by 4 numbers, not just length, width, and height, but length, width, height, and time. So Einstein introduced the 4-dimensional chessboard, and then in string theory, which is what I do for a living, in string theory we're up to 11 now, 11-dimensional hyperspace. So we work in hyperspace when we want to calculate the motions of a vibrating string, to calculate the properties of quarks and leptons and Yang-Mills particles. So we think that the universe is much bigger than we thought. The universe is not just 3-dimensional, not just 4-dimensional as Einstein thought, but we think the universe is actually 11-dimensional. And if you want to know more about where these other dimensions are and whether you can travel in these other dimensions, get a copy of my other latest New York Times bestseller, The God Equation, The Quest for a Theory of Everything. Well, unfortunately, that's it for Science Fantastic. Get a copy of my latest New York Times bestseller, Quantum Supremacy. When we compute not on digital ones and zeros, we compute on electrons, the ultimate building block of matter in the universe. Find out what the excitement is about. In fact, 60 Minutes will do a series, a show on my book and other developments in the field. The book, Quantum Supremacy.
Get healthy, not high, with 100%